Okay, solving logarithms and exponential equations. We're going to use like basically four methods. I try to label these as such, or the four different scenarios that you'll come across. I say here, take out your notes and figure out what your properties of logs are. We've kind of narrowed down the properties of logs quite a bit here, but essentially is that you want to know your log and your inverses. For example, if I've got 2 to the x power, to get rid of the base of 2, I pick log of base 2, and that leaves me with x. Or vice versa, if I've got log base 4 of x, I got to make that the exponent of 4, so they'll cancel out and I'm left with just x. Okay, so here's one scenario. I want to make the bases the same. And before I do that, I'm going to ask you kind of this, like say 2 to the x power is equal to the third power. What's the answer for x? Well, x must be 3, because if the bases are the same, the exponents have to be the same. So what I'm going to do is I'm going to rewrite 32 as 2 to some power. Okay, so you can do a factor tree for 2 and that way. Or maybe you remember from before, but this 32 is 2 to the 5th power. And that's raised to the x minus 1 is equal to 2 to the 4x. So essentially, since they're both 2, I can just solve the exponents. And remember here, I'm going to multiply those exponents so it looks something like this. So just solving some linear equation here. I'd add 5, subtract 4x, so x is equal to 5. Okay, easy enough. I just made the bases the same. I rewrote 32 as 2 to the 5th power because this was 2 to whatever power. Okay, here's another method. I could take the log of both sides. It really doesn't matter what log you pick, but since this is kind of stressing the idea of inverses, this is a exponential with base 4. So there's your 4, there's the base. I'll pick log base 4. Okay, those would cancel out. And log base 4 of 15. There is a change of base, so it's the log of the big number, 15, over the common log of base 4. So that's log base 10, log base 10. The whole purpose of that is because you can actually use your calculator to get that. So I can take log of 15, enter, divided by log of 4, enter, and get 1.95. Okay. Here's another scenario. They are logs, but they're within the same log. So this is in the log base 4. So I've got x plus 3 is equal to 8x plus 17. Okay, now I should add that I probably should be looking for extraneous solutions because I can't have negative logs, take the log of negative numbers. But if I go back and I check this, negative 2 plus 3 is 1, I'm good there. That's going to be negative 16 plus 17, that's going to be 1 as well. So log base 4 of 1 is the same thing as log base 4 of 1. I got it right. Okay. And then lastly, here's my last one. I really try to emphasize it this way. So I try to make these little drawings, okay, and I leave a big old space to just kind of emphasize that I'm going to put a big old 4. Why? Because log base 4 and exponential with 4 are inverses. So x plus 3, and 4 to the second power is 16. So subtract 3 and get x is equal to 13. Now, why did I pick the 4? Because of that little 4 right there. Okay, so those are the first 4 scenarios. Here we go. I'm gonna take away the 3. So 22. So I can't change 22 into 5 to some power. I could have for 5 to the second power, but I need to get rid of that plus 3. So what I'll do is I'll take log base 5 for both sides. That will cancel that out, and I'm left with x plus 2. And log base 5 of 22. I'm going to subtract 2 from there. And oftentimes I'll ask you for calculator ready form, so I won't give you the calculator. I'll just expect you to write it like, hey, here, I'm ready to type it in. So your change of base for that log will be log base 10 of 22 over log base 10 of 5 minus 2, and that would get you your answer to that one. Okay, this is something that we would have done in the past. We don't necessarily do it, so I'll rewrite this for you real quick. So it works out to be log base 2 of x squared minus 7x. Okay, equals 3. There we go, that would be better. How did that plus turn into that? You can ask me in class if you really want to. But since it's not a log of both sides, what I'll do is I'll make that an exponent with base of 2. Because those cancel out, and you get x squared minus 7x, and then 2 to the third, so 8. Subtract 8, so we get x squared minus 7x minus 8. Factor this, x minus 8, x minus 1. Sorry, take that back, x plus 1. Set those both equal to 0, so x is equal to 8 and x is equal to negative 1. Now, the only problem is if I were to put in a negative 1, maybe it won't work out. So let's see, negative 1 squared is 1. Negative 1 times that is plus 7. Okay, we're still good. So 8, I believe, will work. 64 minus 56 will get you that. Yep, so there we go. They both work out. Compounding interest, okay. So let's say I actually know what I deposited. I want to know how long it's going to take to get to that actual amount. We are going to compound, I believe, quarterly. So n is equal to 4. It looks kind of something like this. So here's my end amount. My initial amount. So there's P, there's A. Okay, 1 plus my rate, 0.02 over n, which is 4, because it's quarterly. And then 4 times x, because we're looking for t or time or whatever. Okay, so what I'm going to do is I'm going to simplify the base as much as possible. 0.02 divided by 4 plus 1. So that's going to be 1.005 4x. Divided by 2,000. So I'm trying to get the base by itself first. So 1.25 equals 1.005 to the 4x power. And as strange as it sounds, I'm going to take log of 1.005 and log of 1.005. Yeah, sounds gross. But log of 1.005, 1.25, and that will leave me with just 4x. Take that divided by 4. So this I would actually take into my calculator, go log base 10 of 1.25 divided by log base 10 of 1.005. So log 1.25 divided by log 1.005. Okay, so that is I got 44.7. Okay, now remember that guy right there, so I'm going to divide that by 4. And I get x, or t, is about 11.18. So about 11 years and maybe like a couple months. And that's how you use logs and solving for logs. So I hope that